Hey guys, welcome to day 4 of our week 2. We are going to be working on lesson 16-4 today. And yesterday you guys worked on how you can find the perimeter of an unknown side length. And today we're going to talk about how are perimeter and area related. So we know that they are different, but they can also be similar as well. So what we're going to take a look at is our LEQ. So how our perimeter and area, I like to shade in area so that we know that area is what's on the inside. Perimeter, remember, is the distance around. And area is length times width. So we want all of the stuff inside the shape. Okay. And how are they related? How are they similar? How are they connected somehow? So what you're also going to find out in upcoming up through these lessons is that they could have a perimeter of, say, 16 inches, but their area could be something different. Okay, sometimes they'll have a different perimeter than they do in area. So let's go take a look at what your visual learning will look like for the day. And it says here at the top, Beth, Nancy, and Marcia build rectangular pens for their rabbits. Each pen has a perimeter of 12 feet. So all of these perimeters, when you add all of them up, they're going to be 12 feet. Which rectangular pen has the greatest area? All right, so we know that all of the perimeters here are 12 feet. So let's see, if this is 1 foot, this is 1 foot as well. This would be 5 feet. This side is 2 feet, so it's this side. If this is 4, so it's that side. Let's take a look at the square. We know that a square has all sides the same length. All right. So when you add all of these up, their perimeter equals 12 feet. All right. So it says drawings help you see how the rectangles are similar and different. All right, so let's first take a look at Beth's plan. So Beth's plan looks like this pink shape down here, and we already know, looking up at the top here, that her perimeter is 12 feet, just like everyone else's, but this side is 5, because I can see 1, 2, 3, 4, 5, and this side right here is 1. So if I add up the perimeter here, we have 5 plus 1 plus 5 plus 1, which is 12 feet. Now remember, to find the area, you need to multiply the number of rows by the number of square units in each row. So we would do 5 times 1, okay? And 1 times 5 or 5 times 1 would give us 5 square feet. So Beth's pen has an area of 5 square feet, okay? So let's take a look at Nancy's plan. So Nancy, we know here, her perimeter, we've got 2 feet, 4 feet, this is also 4 feet, and this is 2 feet. So if we add all of that up, we get 12 feet. So her perimeter is also 12 feet. Let's find the area. So remember, we find the area by length. Area is length times width. So if we multiply 2 times 4, we get 8 square feet. So Nancy's pen has an area of 8 square feet. Okay, so I'm going to put 8 square feet right here. And let me go ahead and do that over here with Beth's plan too. Because the inside is 8 square feet. Nancy's is 8 square feet. Let's go ahead and look at Marcia's. So we know Marcia's is a square, and all of these sides are the same length. So if we add up all of her sides, 3 plus 3 plus 3 plus 3, we get 12 feet, okay, her perimeter. And let's go ahead and find the area. So we find area again by length times width, and 3 times 3 gives us 9, so 9 square feet. So Marcia's pen has the greatest area, which is 9 square feet, because if you compare them, Marcia's was 9, Nancy's was 8, and Beth's was 5, okay? And our question that we had to answer was, which rectangular pen has the greatest area? So we can say that Marcia's has the greatest area because her area is 9 square feet. Okay guys, so for your lesson today, you're going to go ahead and log on to Pearson, and you're going to complete the activities for 16-4. You're going to do the visual learning, and then you're also going to do the practice buddy. All right, let me know if you have any questions.